which one has more energy? I hope you pick the green light in your head. Green light has more energy, not the red. Meaning, when I buy these lasers in the box, it says, what does it say? Be careful, don't shoot it at your eye, blah, blah, blah. Well, to be honest, you can shoot a red laser at your eye, at Logan's eye all day long. He's going to be okay. But wait a minute, Logan. If I pulled out a blue laser and shined that, now I'm going to cause damage to his eye. Now I am going to cause, because it's the right frequency. And that frequency is so strong that it could push electrons off of the surface and damage it. So let's go back. Do you remember when you were a kid and there was probably like a solar eclipse? Or was it last year or the year before there was that solar eclipse? And what happened? Your schools or high schools, places had like those special glasses to put on, right? Well, do you ever wonder, well, why do I have to wear these? You say, what, I'm going to damage my eyes? How is that going to happen? And guess what? I looked at it. Guess what I did too? Was it a year and a half ago? I looked at it too. I was like, oh, I want to see it. And don't put these, filters on my eyes. I wanted to see it. But guess what? I saw it and it was really cloudy that day. I don't know how it was over here. I went 3.5 hours out. I made all my kids take off from school to go with me. All the way to the oldest one, almost 30. He obviously had to take off from work. But it was like a science teacher's perfect, family day trip, okay? What I'm saying is, why should you not look at the sun during an eclipse? Well, that's because the sun is made up of white light, which is all the colors. Remember how they just said, whenever you saw that video, it looked like the rainbow of colors were spreading out? That's because the sun is composed of all of those. Now, whenever we have those eclipses, it gets a little bit more intense around the edge, as well as there's other types of energy that's coming off. But when you're looking at the sun like this, okay, those high frequencies are really shooting at your eye. They really do cause damage. Just like if I had a laser that was so happened to not be red, but to be blue or indigo or violet, and then shoot it at Logan's eyes, I am now going to cause damage to somebody. Don't do that. That would be cruel. I think you would definitely go to jail or something, right? Like, that would be, no. That would be bad. But definitely don't do that.
As long as I blackmail my sister into not telling anyone, it's fine.
Well, we just recorded it right now. I definitely would say JK. It's definitely recorded. Now, Einstein said that light is made up of photons. And he says that if you have the correct threshold, you're actually able to make electrons bounce off of a solid surface. Okay, so Einstein was proving Isaac Newton's experiment, but he was doing a better job of it. Einstein proposed that light consists of what we call quantas, and these quantas are called these photons inside the pockets or packets of quantas. He suggested that the energy in each quantum, and we will get more in detail about this, particularly next unit, of light was equal to the frequency multiplied by Planck's or Planck's constant. We have another equation that we're going to do this equation next unit, not now. We're just talking about it this unit. And that the photon with this frequency over a certain threshold would have enough energy to eject a single electron off of the surface. That is crazy. Photons have no mass. What? But it does have momentum. Whoa, stop it right there, Einstein. And they do have energy. Okay, let's talk about that. That makes no sense to me. Do you remember our formula chart? P, lowercase p, is momentum. P equals m mass times velocity. So does light have a velocity? Yes, it does. 3 times 10 to the 8th power. But wait a minute, light or photons have no mass. How in the heck can it have momentum to push electrons away? That doesn't make sense. But Einstein says it does. If we use it in what we call Planck's constant up there, multiply it by the frequency, we can figure out how much energy that color of light will have. And if my surface has a certain threshold or a certain number, and my light has the same exact frequency, I can make electrons jump off. And that is what Einstein calls the photoelectric effect. I have a cheesy video at the end, so just give me a moment and I'll show you the cheesy video. It says here that the photoelectric effect is used in photocells which convert a light into electrical energy. Whoa! What do you call that? Some people put this on the roof of their house. Solar panels. What? Einstein was coming up with solar panels back then. Is that not crazy? He used Sir Isaac Newton's theory that light acts like a hard particle even though it has no mass, and we can make it hit a certain surface and convert light energy into electrical energy. That is flipping crazy that Einstein was actually coming up with those photocells or solar panels at this time. Now, going along with this, the photoelectric effect has a lot of applications. For an example, automatic switches. Wait a minute. Those switches on the traffic signals. And what do I mean? Is there a cross guard? Because I live in Tech City, and when I go and pass the high school and the middle school, there's all those cross guards. Is there a cross guard that goes and turns on to flip the switch for those lights in the morning? No. There's a little panel. That stores all of this, converts that electrical energy into electricity, and those lights start to flash on a timer. Look at this, Einstein. It also works for burglar alarms and elevators. Solar panels is what we just said. Some of us have those on our house. And maybe you've had a solar calculator. You know, those ones where you actually have to shine the light right there. So, oh, look, there it turns on because I shine the light. And once I take the light away from it, after a while, it turns itself off, right? Because it has a solar panel. Every time we see solar panels from here on out, what are we going to say? Thanks, Einstein. Good job, buddy. All right, now I'm going to pause it for a moment.